section 2.5, the product and quotient rules. There are a few things, like I hadn't done calculus since college, right? So that would have been 1999, 2000, okay? And so when I started teaching calculus again in 2020, it was 20 years later. So I hadn't done calculus in 20 years, right? And there are a few things that you just don't ever forget, and this is one of them. The other thing was derivative of e to the x is e to the x. The derivative of sine is cosine, and the derivative of the natural log of x is 1 over x. And those are the things that you just don't forget because we'll do it so much. All right, so here we have the product and the quotient rules. These are written out. So what we have here is, this is saying we want the derivative of two functions that are being multiplied together. So we have f times g. And so the way that I think about it is we have two things here. This is going to be the first thing times the derivative of the second. The derivative of second. The first times the derivative of the second plus the second times the derivative of the first. And that pretty much is how I remember it. First times the derivative of the second plus the second times the derivative of the first. And that's exactly what Mr. Taylor has written here. F for first thing and F for second. First times the derivative of the second plus the second times the derivative of the first. So that's exactly what he's saying here in this sort of shortcut way, right? This is very formal notation, and I will use this a lot because when we go to not using functions, but using, you know, the graph of g of x or the graph of f of x, then we'll use this notation because I think that it's very, very helpful. But yeah, so f is first, and then s prime would be the derivative of the second, and second times the derivative of the first, okay? The quotient rule, I have a saying for, and what my calculus teacher taught me. Here we go. We're going to write this out. Low d high minus high d low all over low squared. That is the quotient rule. Low d high minus high d low all over low squared. Say it out loud. Evidently, there's a song I hear people use, but I think low d high minus high d low all over low squared works. So what is it? So again, quotient means we have a fraction here. We've got a numerator and denominator. And of course, low is referring to the denominator, okay? And so it's the denominator function times the derivative of the f function, the derivative of the numerator. So that would be the low d high derivative of the high thing on top, okay? Minus the high thing, or the f function, the thing on top, times the derivative of the bottom function, high d low, so the derivative of the low thing. And then it's all over the denominator squared. Let's see, how did Gary do it? He said we got a top and a bottom function, and so he did bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. Okay, but I like low d high minus high d low all over low squared. All right. Any one of these derivations, however you want to think about it, is all going to be just fine. And so we're going to go ahead and do a little bit of practice with this stuff. Let me get my notes here. And again, most of calculus is figuring out the best way, the most efficient way to do something. And so there are lots of ways that we can do things. And for instance, this problem number 1 here, I actually did in 2 different ways. And that's because there's a couple of different ways we could do this. So you already have, even before we had the product rule, you have a way to do this. What would you do without your product rule knowledge to go ahead and find the derivative of this first function here? What could you do? Could you multiply them together? For sure. You could FOIL these together, and we could get a new f of x function. Let's see. First times first, 3x squared times 2x would give me 6x cubed. The outside would give me 6x squared. The inside would give me negative 4x. And last times last would give me negative 6. And now, since I multiplied those all together, now I can really easily take a derivative, right? So f prime of x would be what? 18x squared. 12x? That's right. I knew what you meant. And then minus 4. There we go. All right. So, and that totally works. So we could clean things up and take a derivative. However, yeah. Wait, where were? So first times first, 3x squared times 2x is 6x cubed, right? The next one. Oh, you're totally right. That's supposed to be a 9. Thank you. Okay, that makes total sense. You're totally right. 3x squared times 3 would be 9x squared. And then that would become 18. Thank you. I would have looked at my answer and been like, oh, what did I do there? Okay, great. Okay, now that we've worked out the kinks in that, you can see the kinks, the problems that do arise when we try to do things. That's okay. Okay, but say I want to do the, oh, that's so funny. Gary did the exact same thing. I didn't even look at that. That's so funny. Say I want to use the product rule, because what we have here is we have a first thing. So that would be his f, his first thing there. And then we also have the second thing being multiplied together. And so we have a first bit and a second bit, and it's the product of two things. And so if we want to find the derivative, we would do the first thing, so that's going to stay the same, 3x squared minus 2, first times the derivative of the second. So we want the derivative of our second piece here. What's the derivative of 2x plus 3? Yep, just 2. First times the derivative of the second plus the second bit, 2x plus 3, times the derivative of the first. What's the derivative of 3x squared minus 2? Just 6x. Okay. And that's it. First times the derivative of the second plus the second times the derivative of the first. So what do we do from there? Well, again, we're going to clean it up. And if we clean it up, I'm going to distribute my 2, multiply that in. So that's going to be 6x squared minus 4 plus, here I'm going to distribute in my 6x. So 2x times 6x is 12x squared, and 3 times 6x is 18x. And one last step then, f prime in terms of x. 6x squared plus 12x squared is 18x squared plus 18x, and then the minus 4. And so we get the same answer. Which one was easier? It certainly seems like less work. But I mean, we did make a mistake. So maybe I made a mistake. You didn't maybe. But, you know, they both work. And that's kind of a cool thing. And again, this is most of where doing lots and lots of problems comes in, to figure out what's the best way. And so really that's the option. Here we have a quotient. And sometimes your quotient can be cleaned up. But this looks rather complicated. I don't want to try to clean it up. So I'm just going to go with, hey, let's just take a derivative. Low d high minus high d low all over low squared. And so we have our low piece, our bottom piece, and our top piece. And we're going to go ahead and find our derivative. So y prime low, so that's 2 minus 3x. D high, the derivative of the top thing. So what's the derivative of our numerator? Four x minus 4. Low D high minus, put a big negative sign in red there. High, so that's unchanged, just the numerator. 2x squared minus 4x plus 3. D low, what is the derivative of the low thing? Negative 3. All over low squared. So 2 minus 3x quantity squared. All right. Low D high minus high D low. All over low squared. All right, questions on that? It's a pretty easy pattern, right? Low D high minus high D low, all over low squared. I'm going to say it as many times as I can. All right. Again, you could clean this up, but I'm not going to do any more than this. You don't have to. Distributing a negative is a very common mistake. So if you were to clean this up, to simplify it, do the negative last. You're going to multiply in your negative 3, and then that negative gets distributed to everything to the right. So be careful. Yes, ma'am.
Would this answer be respectable on the AP exam?
Absolutely.
Okay.
Absolutely. And in fact, there's even a lot of multiple choice questions where they leave it in this sort of expanded form. And they don't actually go ahead and multiply everything and clean it up. All right. So, however, there are many times where they do clean it up, and you do have to figure out which one it's going to be. So this is definitely more of a multiple choice kind of question, I would say typically. Questions on those? That's it. Those are the patterns today. All right. Over here, again, we have a choice here. It's a quotient, so we could use our quotient rule. We could also rewrite this in a nice, friendly power manner. And so, again, I'm going to do that so you can see both methods here. I would rewrite this function as a scalar, so negative 9/5 times x to the negative 2. Pull off that coefficient in front and then use my powers with exponents however they need to be, and then we can just multiply. So y prime would be negative 9/5 times negative 2 times x to the negative 3. Drop your power and subtract 1, so that would be one answer possibility there. Now, if we wanted to do the other method, the quotient rule, low would be 5x squared. The derivative of the high, d high, would be, what's the derivative of negative 9? 0. Minus high, so minus the negative 9, times the derivative of the low thing. What's the derivative of the low thing? 10x, all over low squared. So, 5x squared quantity squared. If we were to clean this up, 0 times anything is 0, so that term goes away. Oh, I'm laggy. And then here we have 90x on top. On the bottom, what do we get in the denominator? It's low squared, and so 5x squared quantity squared is what? $25 x to the 4th. Remember, this would be 5x squared times 5x squared. So 5 times 5 is 25. Okay. Are they the same? That actually cleans up. So these reduce by 5. So 90 divided by 5 is what, 18? And then 25 divided by 5 is 5. X on top, x to the 4th on bottom, that would be x cubed underneath. And that is the same as this. Okay. Interesting, yes? Okay. So there we go. All right, last one here. This one is a product. We have 3e to the x times sine of x. So again, it is a product rule. And again, there's multiple ways to do this. This 3 could be pulled all the way out in front, and I could worry about it at the very end, which is what I did initially. You can see here in my practice notes that I go through and do before I teach you. I run through and do it, and you can see I pulled that 3 out in front. And so my first thing and my second thing now, I do deal with differently. But that's how you could do it. You can pull that off. Or you can think about it as just part of the first thing. And in blue, then we have the second thing. And so we can do our little derivative product rule. So g prime of x, the product rule is first. So that's, 3e to the x. First times the derivative of the second. What's the derivative of sine of x? Cosine of x. First times the derivative of the second plus the second, so that's sine of x, times the derivative of the first thing. What's the derivative of 3e to the x? 3e to the x. Very good. You'll notice I like to just go ahead and typically I'm just going to keep everything in parentheses as the first derivative of the second, times second derivative of the first. I think it's a good way to keep things straight as well. You'll never go wrong when you're using parentheses, so I highly encourage that. You can totally leave it like this. Typically, we would rearrange things so that the coefficients are the leaders here. So 3e to the x sine x is typically how you might rearrange that. And you can see you get the exact same thing as I did when I pulled out my 3, but I did have to distribute it. Again, either answer are equivalent. All right, so no change there. All right, product rule is first times the derivative of the second plus the second times the derivative of the first, and the quotient rule, low d high minus high d low all over low squared. Please say them out loud as much as possible so that you remember those two rules, because we literally will use them all year long. Okay. All right, ladies and gents, let's see. Assignment. What was my assignment for this? Okay, I wrote it. I wrote it right there. Look at that. Convenient. Okay, assignment 2.5 is numbers 1 through 10, 12, 16, 20, 21, 20. I want to make sure that this is right. 23, 29, 30, and 31. I want to make sure that's right. I might have changed it on the calendar. Let me see. Is that what it says? Okay. 20, 20, 20. Okay. Great. 29 through 31. Yeah. And always, as always, please feel free to check the answers. We'll look at my work. Super. Well done.